Hello everyone and happy Monday. Today we're going to be looking at some more quadrilaterals. We're going to be looking at rhombuses and squares. If you the type of person that likes to do a little warm-up problem, here's a little warm-up problem for you. Alright, so today we're going to be looking at using the properties of rhombuses or rhombi and squares to solve for missing sides and angles. So the same type of stuff that we did for rectangles, we're going to do for rhombi and squares. So just to go through, starting at the beginning, we looked at parallelograms. And then we looked at rectangles. And a rectangle is just a specific type of parallelograms. So everything that applies to a parallelogram also applies to a rectangle, because a rectangle is a parallelogram. Same thing's going to be true for rhombuses. Everything that's true for a parallelogram is also true for a rhombus. So that's where we have this middle section right here. So a lot of you guys probably first heard about rhombuses as sort of like a tilted square, and that's an okay definition. A rhombus is basically a parallelogram with four congruent sides. So all of these things right here in the middle in blue, these things right here are just the parallelogram stuff. So since a rhombus is a parallelogram, all of the parallelogram stuff is true. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Now there are a couple extra things that are true for a rhombus, and these are over here. So the first one is that the diagonals of a rhombus are perpendicular bisectors of each other. So they not only are bisectors of each other, they're also perpendicular. That's why we have this 90-degree angle right here. So the additional piece there is the perpendicular part. We already knew the bisector part. And also the diagonals of a rhombus bisect the angles of the rhombus. So these angles right up here, all those corners, all those angles are cut in half. The diagonals bisect those angles of the rhombus. So these are the new things that apply only to rhombi. So let's look at a couple examples. And always, it wouldn't be geometry class unless they tricked you into doing some simple algebra. So let's go ahead and label this problem. So if fk equals 5, so we know that fk is 5, and we also know that fg is 13, so fg is 13, we need to find kj. So kj is, where's kj? Right here. So we need to figure out what this length is. Okay, let's think about some things we know. Sometimes it's okay to just over-label it. Well, we know this is a parallelogram because they told us it's a rhombus. So we know that opposite sides are congruent, so maybe we could label this as 13. Since it's a rhombus, these are all perpendicular bisectors of each other. So these angles are all 90 degrees in the middle here. So that might help. What else do we know? We do know that the diagonals are perpendicular bisectors of each other. So that means that these two segments are congruent and these two segments are congruent. Okay, so we're trying to find kj. Well, if we could label some more pieces, we would be able to do that with Pythagorean theorem. So check it out. We know that this is 5, so that means that this is also 5. And then look at this triangle here in purple. That is a right triangle. With one leg is 5, and the hypotenuse is 13. We just need to figure out what kj is. So let's figure it out. Let's do Pythagorean theorem. So Pythagorean theorem tells us that the one leg squared plus the other leg squared equals the hypotenuse squared. So we get 25 plus b squared equals 169. So we'll get b squared equals, let's subtract 25 from both sides. So we get 169 minus 25. We'll figure out what that is. B squared equals 144. So we'll take the square root of both sides, and we will figure out that b equals 12. Boom! So b equals 12, which means that kj equals 12. Problem solved. So again there, just to reiterate, what did we use? We used the fact that we knew that the diagonals were perpendicular bisectors of each other. Not just bisectors, but perpendicular bisectors. Let's move on to the next one here. So this one says, if the measure of angle JFK equals 6y plus 7, so let's go ahead and label that KFJ. So KFJ, that's right here, and that is 6y plus 7. And the measure of angle KFG is 9y minus 5. They want us to solve for y. Well, again, we need to use something that's specific to rhombi here. And that thing that's specific to rhombi is that the diagonals bisect each other. So we know that these two angles are congruent. So we are just going to solve this simple algebra problem. 9y, oh, that's weird, 9y minus 5 equals 6y plus 7. And then we'll just solve this. So maybe add 5 to both sides and subtract 6y from both sides, and we would get 3y equals 12, which means that y equals 4. All right, so just some simple algebra problems solving for those missing angles using the properties that we wrote down on this sheet. Okay, I thought it'd be a good time to maybe pause here and make a little Venn diagram, because there's a lot of words floating around right now. The very first thing that we learned was polygons. We talked about polygons, we talked about interior and exterior angles, but polygons is a pretty big category. And then a specific type of polygon is a quadrilateral, meaning it has 4 sides. So then we have quadrilaterals. A specific type of quadrilateral is a parallelogram, which is what we've been doing for the past couple days. Parallelogram. Now today we learned a specific type of parallelogram. We learned about a rhombus. So a rhombus is a parallelogram, which means that it's a quadrilateral, which means that it's a polygon, so on and so forth. We also learned about rectangles. Rectangles are also parallelograms, and I'm going to add in a circle just like this. This is going to be for rectangles. And remember, for Venn diagrams, we have a little bit of overlap here in this particular case because some rectangles are rhombuses. They're both rectangles and rhombuses. So think about what that thing would be called. That is a square. A square is just a rectangle and a rhombus. That's really all you need to know about a square. Everything that's true about a rectangle is true for a square, and everything that's true for a rhombus is true for a square. So if you're looking at your sheet, your square thing looks kind of like this, and a square is just a parallelogram with 4 congruent sides, or all congruent sides, and 4 right angles. Remember that it is a parallelogram. right? We all know what a square is. Okay, because a square is a parallelogram, a rectangle, and a rhombus, all of the properties that we've learned for the past week or so also apply to squares. So anything that you can think of that we've learned so far, it definitely applies to a square. So all sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and all angles are congruent, or all angles are 90 degrees, right? Because if they're supplementary and congruent, that must mean that they are both 90 degrees. We already knew that. The diagonals of a square are congruent, they are perpendicular, and they bisect each other. And they also bisect the angles of a square. So I know this seems like a lot of different things to remember, but basically it's just all of the rhombus stuff and all of the rectangle stuff and all of the parallelogram stuff put together, because a square is all of those things. So if you don't have this copied down, make sure you pause the video and get all of this copied down. This will be really important. I'm going to do my best to label the corners of this. To label this picture. So we know that these are all 90 degrees. We know that these are all 90 degrees. We know that they are perpendicular bisectors of each other. We also know that opposite sides are congruent. And I'm going to draw one more picture here. We know that the diagonals are congruent because it's a rectangle, right? So this and this, those entire lengths are congruent. We also know that they bisect each other. So something that's important about a square is that obviously those are congruent because that's diagonal is bisected, and these are also congruent because they're bisected. And not only are they congruent to each other, all four of them are congruent. So that's kind of an additional thing that you might need to actually draw like a little separate picture. Okay, very last problem. Looking at some coordinate geometry problems. So you want to give the most specific name for this quadrilateral, and we are only given points, so we know we're going to have to use slope and things like that. So we have a quadrilateral JKLM. Let's go ahead and draw it. Let's say JKLM. So let's first try to prove that it's a parallelogram. So let's do that by finding the slopes. So the slope from J to K is negative 11 over plus 3. So this slope right here is negative 11 thirds. All right, let's look at some other slopes. We also need the slope of KL. So from K to L is the change in Y is minus 3. And the change in X is minus 8 minus 3, so it's minus 11. So that's negative 3 over negative 11, which is 3/11. Let's look at some more slopes here. Let's get the slope of LM. So the slope of LM is the change in Y. Change in Y is negative 14 to negative 3. That's plus 11. And from negative 3, the change in X to negative 6 is minus 3. So our slope here is 11 negative thirds, or just negative 11 thirds. And then one more that we have to do, and that's from M to J, or J to M, doesn't really matter. So my change in Y is going to be plus 3, and my change in X is going to be plus 11. So my slope is 3/11. Okay, so let's try to figure out what this shape is. Hopefully everybody can see that this is definitely a parallelogram because the opposite sides are parallel, because they have the same slope. So we can label our picture like that, right? Opposite sides have the same slope, so we know that they're parallel. So it's definitely a parallelogram. Let's see if it's a rhombus. A rhombus is just a parallelogram with 4 sides that are congruent. So are all of these sides congruent? We can check that pretty easily using Pythagorean theorem. So let's try to find the length of KL. So the length of KL, if you think about it just as a triangle right here, it has a side of 3 and a side of 11. We just need to do essentially the distance formula, which is really just Pythagorean theorem. So the distance from K to L, if you remember the distance formula, is just the square root of 3 squared plus 11 squared. All right, and that's some number. I'm not going to go through and actually figure out what that number is. I just want to find all the other lengths. So JM equals is going to be the exact same thing. Right? So now we know not only are these sides parallel, these sides are congruent. We can do the exact same thing for ML and JK, and we could sort of draw a triangle, and we would realize that we have a triangle with one side 11 and the other side 3, exactly the same as all of these other segments. So I don't really know what that number is, but I could punch it into a calculator and figure it out. But we know that we're going to get the same calculation every time. The square root of 3 squared plus 11 squared. So now we know that all of these sides are congruent. All right, so we know this is definitely a rhombus for sure. Let's try to see if it's a rectangle or a square. So probably the thing that I would look for is, do you know that these corners are perpendicular? And we do know the corners are perpendicular. The corners are 90 degrees because 3/11 and -11/3, those are opposite reciprocals of each other. So since they're opposite reciprocals, that means that they are perpendicular. So since they're opposite reciprocals, that means that they are perpendicular, which means that, and you could check all of these, but you would be able to see that these are all 90 degrees. So now we do know it's a rectangle. If we know that it's a parallelogram and a rectangle and a rhombus, then we also know it's a square. So the most specific name that we can give is square. All right, I hope this was helpful for you guys. Have a fantastic day. Make sure you're asking your teachers if you need some assistance.